Hello everyone. In this video we are going to see a smart grid measurement technology. So before we begin with the smart grid measurement technology, we will see that there are various technologies in smart grid measurement technology itself, which is synchronized phasor measurements, smart meters, wireless sensor network, IoT and geographical information system. We will study everything one by one, starting with the synchronized phasor measurements. Basically, the first of the PMU was developed by Macrodoin along with VTU, and the new standard was IC 6025511812018 for synchronous phasor for power system measurement. Before we begin to what is synchronized phasor measurement, we will know what is actually our GPS, because it will help us understanding about synchro phasor measurement. So we already know that the satellite, if there are 3 satellites, it give me 2D view. If there are 4 or more, it give me 3D view. So when we talk about GPS, it uses satellite technology with signal receivers and highly accurate clocks, because we are residing here. So there are total 24 satellites revolving around the earth, and we know that when we want to check particular location of that object, so they are given by 21 satellites and 3 spare satellites which are revolving around the earth. So total of 24 high altitude satellites we are having. In this, it is used with signal receivers and highly accurate clocks to determine the position of an object in earth. We know that satellite orbit the earth around twice a day, and when it revolves twice a day, it will give precise time and position. Means what? Latitude, longitude and altitude information. Basically, where we can use this satellite, so it will be used in traffic management, asset management, defense, utility, property mapping, infrastructure activity. Then comes our GPS in power system. So when we talk about GPS in our power system network, so it is used for efficient monitoring and control of power transmission and distribution network. It gives me accurate measurement of our voltage and angle at all the buses. For example, this is my buses. This is all my buses. So it will give me the accurate information of some particular bus. That should be time stamped and that should be time synchronized. And it helps, the GPS helps in common access timing pulse that is less than 1 microseconds at any point on earth. It helps in time stamping, accurate measurement, synchronized measurements. Then comes our pulse. Then comes our phasor. So what is a phasor? A phasor represents a sinusoidal signal with a magnitude and a phase angle with respect to reference. Okay, for example, let us consider one line here. Okay, and I'll draw one circle here. So this is my phasor. As I try to keep on moving this part in this fashion, what will happen here? I will start from here, from 0. Slowly it will increase. It will reach the peak here, and after that it will reduce from here. In this fashion it will try to reduce. So this is my phasor, because it represents what? A magnitude and a phase angle with respect to reference, right? And a phasor is a RMS value of sinusoid. ये कौन सी वैल्यू होती है? That it's a RMS value of a sinusoid signal. If I see synchro phasor definition, so what is synchro phasor now? We will come to see. So 1 PPS signal that is received from GPS. I have already told the GPS signal that is used to get the accurate or precise information of an object. So what we take from the GPS is 1 PPS time signal that is obtained from the GPS. So let's consider this is my 1 PPS time signal that is obtained from GPS. And at particular point of the time, we will get the waveform from our system also. We will compare these two waveforms and we'll come to know that this waveform is basically 90-degree phase ahead. So we can make this system 90-degree ahead or 90-degree lagging as per our waveform which we get from the system. So The phasor measurement technology enables measurement of voltage and current phasors with respect to the reference signal. For example, we are having one substation. 1 minute. Yeah, we are having one substation where we are getting the information for the voltage V1, and this is our substation 2 where we are getting the information for the voltage 2. Right. So from here I will get some pulse, and from here I will get some pulse. So we will compare these two, and we will see that how much voltage it is getting lag or lead, and according to that DFT techniques or any other techniques will be used for finding out magnitude, phase angle with respect to our GPS clock. Also, it helps in getting snapshot information of the power system, relative information across all the buses, helps taking quick action. Then comes our anti-alyzing filter. Anti-alyzing filter, what is anti-alyzing filter? First of all, before seeing the anti-alyzing filter, we will see the definition of what is alyzing. See, alyzing is what? If cutoff frequency Fc is greater than 1/2 of the sampling frequency Fs, the Fourier transform of the sample data overlaps. So what we say is that if Fc is greater than 1/2 times of Fs, what will happen here is the sampling data overlaps. So here comes Nyquist criteria, which says that bandwidth of the input signal must be less than bandwidth of the sampling signal, which is here, must be less than half of the sampling frequency utilizing and obtaining the sampling data. So if you use a Nyquist criteria, there is no overlap of the signal, and this is what anti-alyzing filter do. It consists of low pass RC filter, and the band limited the input signal to a value much smaller than one required for meeting the Nyquist criteria. Then comes our phasor measurement unit. Now we talked about PMUs, right? So what is our PMU? It's a device to estimate what? A magnitude and a phase angle of voltage as well as current, right? And if you talk about synchro phasor measurement, so it gives me 24 samples per second, which is time stepped, and voltage and angle of that particular bus we can get, direct measurement of frequency and rate of change of frequency also we can get, and helps in executing dynamic processing algorithms such as DSC. Production grade PMUs are also available in market. Now when we talk about network of PMU and PDCs, let's see that in the next video.